Hello. Okay, you should see the desktop. You should hear me by now. You should see the desktop.
Yep.
Okay. Turn up my speaker. I don't have my speaker very loud. Okay. Okay. All right, everybody hear me all right now?
Yep.
Okay,
Yep.
great. Thanks. Yeah, I have my speaker too low. I didn't hear you. Okay, okay. And I need one more window up. Okay, almost everybody's here. Okay, so this is the last week of the semester. Next week is final exam week. In case you don't know, classes don't meet during final exam week. Final exam week is only for taking tests. So now here's the final exam schedule for the university. The university determines when each class takes its final exam. And if you've never seen this before, what you do is you look up what day of the week your class first meets on. Like our class first meets on Tuesday. So you get down here to Tuesday, and we meet at 3:30. Okay, so Tuesday between 3:30 and 4, our exam is on Thursday. So I'm supposed to give you the exam on the day that this final exam schedule specifies it. So all the faculty members are supposed to be using this schedule. Okay, so our final exam will be on Thursday, but it'll be done the exact same way that the previous exams were. So it'll be on Thursday, and what is, I point out here, it'll be available on Brightspace at say 1 o'clock in the afternoon, and you'll have till 11 o'clock in the evening to do it. So you'll have the whole day, so you can arrange your time best way you can. So it'll be just like the 2 previous exams, okay? All right, so it'll be available at 1 on Brightspace, and it'll be due back on Brightspace by say 11 o'clock in the evening. And I'll be here, I'll be in a Zoom meeting during class time if you have questions. And you can also just send me email, like in the previous exams. If someone, I told you, if you're unsure about what a question's asking for during the exam, you can always send me an email and get clarification, okay? So we won't have class on Tuesday or on Thursday, but I'll have office hours. And if you have questions, you can always send me email or arrange for a Zoom meeting, okay? So that's the final exam. It's going to be a week from this Thursday. Okay, so that's the a week from Thursday is the 17th. Okay, we're the 8th, and this week, and that's almost the end of final exam week. The final exam week ends on the 18th. Okay, all right, and the exam is over the whole semester. So it's a final exam. If you look at the syllabus, the final exams were 20% of your grade. The midterms were 15% each. So the final exams worth a little bit more than the midterms were. It'll be a little bit longer. The midterms were about 9 problems. The final exam would be 11 or 12 problems. So it'd be a little bit longer and worth a little bit more than the midterm exams, but it's over the whole semester. Okay, so review for the final, you should review the previous 2 exams, and also make sure you can do the problems on your exams. Make sure you download your exams from Brightspace and look back at them. That's your first study goal, should be to go and review your first 2 exams and make sure you feel comfortable with everything on those exams. So when the semester's over with, you may lose access to those exams. I think you should download them now so you have a copy of them for your records, and also just you should also have them so you can read them real quick when you're studying. So I would recommend you download them and keep a copy of them. So review the first 2 exams, and then here's a review of what we've done since the second exam. Okay, this is what we've covered since the second exam, these sections of the books. And we've covered 2 topics, arrays and classes. Okay, and classes are what we're doing now. We're working on classes now. And you have the last homework assignment is a problem to review these ideas here. Okay, so then there's problems here that are problems on arrays and problems on classes. Okay, so the exam will be roughly a third, roughly kind of a third. Where's a third what we did in the first part of the semester, a third what we did in the second part, and a third what we've done since the second part. Okay, so There'll be a few problems on arrays and classes on the exam, and if statements, while loops, and variables and things like that from the first two parts. Methods, if variables, methods, okay, for the first exam. From the second exam, it was mostly more methods, if statements, while loops, okay? So those are the main topics. So each topic will have a couple problems on the exam from it, okay? So look at the review problems. On Thursday's class, when we meet Thursday, if people have questions about some of these review problems, we can go over review problems on Thursday. That'd be the last day we meet will be Thursday. And then, like I say, if you have questions, you could also send me emails about them. Let me think. Anybody got a question about the final exam before we go on? Anybody got a question about what's going on so far?
Just a quick question about the proportions of the grade. So we only had 4 assignments. That's going to be 50% of the grade still?
Yeah. I'm going to stick because that's what the syllabus says, and I'm supposed to stick with what the syllabus says. Yeah, there were supposed to have been more programming assignments, but I got sick and my wife got sick, and that cut into what I was able to write up. But I'll stick with what the syllabus says. Yeah. So the 4 programming assignments. Pardon me.
I said that's good news.
Okay. Yeah. The general rule of thumb is that the professor is supposed to stick with what the syllabus says. Because that's what you were told at the beginning of the semester. Okay. So yeah, I'll stick with what it says there. Okay. All right. Other questions about stuff so far, about the exam, about the.
Yeah. Would we have the exam on a given time period, like an hour and a half period, or will it be throughout the day?
I said here, it'll be available at 1 p.m. on Brightspace, just like the other exams were, and it'll be due in Brightspace by about, I think, 11 in the evening. So it's pretty much the same way the other exams were. Okay, so give people flexibility. Yeah, I know some people have work schedules they have to work around and things like that. So okay, so it'll be just like the previous 2 exams. You'll download the exam from Brightspace at a certain time, and it'll be due back in Brightspace at a certain time. But otherwise, yeah, and while you're taking the exam, you can send me emails if you want clarification about a question, not how to do a problem. Yeah, I mean, plenty of people send me emails during the exams, and they were pretty honest. People ask for clarification. Nobody asked me, how do you do this problem? Yeah, but if you have questions about, if you're afraid you're misreading a problem on the exam, you can ask for an explanation or a clarification about it. So during the exam, you can send me emails. Okay, but it'll be available at that time, and you can take it when you need to. Yeah, but you have that much time. Okay, so it'll be available then. It'll be due at 11. Just pretty much exactly like the previous 2 exams were. Okay. Other questions?
I had a question about the homework, actually, really quick.
Sure.
So I think I've only turned in 2 of the 4 so far. Are you going to take late deductions on it?
The syllabus says that I reserve the right to do that, and
Okay.
I'm still, but definitely, here's what I say: turn in everything. Okay. And I go by kind of partly by when it gets turned in. People will turn in homeworks the day before grades are due, and I usually do not grade those. Yeah, so I don't have a blanket statement that I won't grade a late homework, but I kind of won't grade something that's turned in a day or 2 before grades are due. So,
right.
But I do say turn in everything. If you have the homeworks done, submit them. You
Okay.
won't lose points that way. You might gain some points.
Right. All right. Thank you.
Okay, so definitely, if you haven't turned in a homework assignment yet, if there's any homework assignment you haven't done, you haven't turned in, you can ask questions about them and you can still turn them in. Okay. Okay. You will get you'll probably get partial credit for them. At this point, you might not get full credit, but you'll at least get some partial credit for them. Okay. All right. Okay. So Okay, now what we want to talk about today is we're talking about, okay, let me close some of these tabs. Okay, otherwise I get mixed up where I am. Okay, here's the review for the final, okay? The review of the part of the class we've done since the final. We're talking about classes. And here's the words. I want to do another example today and just practice with these words. So we're going to do another example today that shows us how these ideas come up in designing a class. Okay, so we're going to do another example today. Last week we designed a class, the point class, and you're using that in your homework assignment. So last week we did this example where we wrote in class a point class, okay, and put a bunch of methods in a point class. So today we're going to do another class kind of like that. Now the point class is part of your homework assignment, but it's written for you in the homework assignment. But we want to design another class and use, another way to say it is we're using all these ideas here. See, there's Mutator methods, accessor methods, constructors, this keyword, scope, static variables. Okay, those are the words here. Okay, there's pretty much a section in each one of these ideas has a section in the book, but we want to do another example where we play around with these ideas and see how we use them. Okay, so what I'm going to do is design a different class on the Java visualizer. Okay, so what we're going to do is we're going to do bank account. Bank account class, we're going to design a bank account class. This is a pretty common example for an introductory class to do. It's kind of a straightforward example to think about. So what would a bank account look like in software? Now, you know what a bank account looks like in a real bank, but the question is, what would a software thing that represents a bank account look like? So what data would we put in a bank account? So remember, a class holds data and methods. And the methods are there to manipulate the data. So the first thing for us to think about is what goes in a bank account. Okay, so pretty much everybody would assume that a bank account has a double, which is the amount. Okay? So the amount of money in the account. Okay, so we'll have an amount of money in the account. And then, but then there's also probably an int that would be, say, an account number. Okay, and there might be a string that is the name of the account owner. And maybe another, I'm thinking, I'm gonna make a string that is the type of the account. And by type, I mean, it's either a savings account or a checking account. Okay, so we'll identify the type of account. So there's some examples. Yeah. Now there may be, in a real savings account, there'd be lots of other data, the interest rate, the social security number of the owner, their address. So there'll be all this data in the bank account, okay, that will be stored as information about for each bank account would have this information. And in a real bank, these bank account objects are stored in a database. See, we'll create, like here now, I can already create a bank account object. So I'm going to create a bank account object. I'm going to create a bank account called account 1. Okay. Now I can't put anything in that bank account yet because I haven't written a constructor for it. But I have said what the bank account holds, so I can go ahead and visualize this. Let's see, what mistake did I make? What did I, oh, let's see.
You need a new keyword.
Oh, thanks. Yeah, when you switch, not every language makes you type the word new. So it's real easy when you switch between languages to forget that you have to put new in Java. In some languages, that's good enough. Bank account equals, and then you're going to construct the bank account. So several languages let you do, like C++ will let you do it that way. Okay, so you need the word new, okay? So I have to say, this is redundant, new bank account. You can't create an old bank account. The word new, I mean, it's really redundant. So some of the programming languages don't require you to use that word new. Okay, all right. So now what I'm going to get is a bank account object full of default values for each field. Okay, so see, there's the bank account object that I'm constructing, but it's initially got default values like a double defaults to 0.0, an int defaults to 0, and strings default to null. Okay, they don't point at anything. Okay, and so then I have an empty, a blank bank account. Okay, but this isn't very interesting. I want to put things in the bank account. Okay, so to do that, I need constructors. So the three things that you would find in most classes is the data that each object holds, constructors for building an object with the initialized data, and then methods for manipulating the data and the object. So in our case, we need a constructor. The constructor always begins with the name of the class. So I would say public bank account. Now I can say, I give the constructor parameters. What do I want the user to be able to initialize? Like here, what I would want to do is I want to say, I want to create a bank account for somebody named Bob. And I want, we'll see, I want to create a bank account, with account number 123 for Bob with deposit of, say, $22. Okay, so that's going to be my constructor. Account number, the name of the person, and actually, no, I'm going to make it a checking account. I'm going to do it this way. And the amount will be, this will create an account that has zero money in it, but it'll have an account number, an owner, and it'll be a type, but it won't have any money in it yet. Okay, so let's do that. Let's create a constructor that takes in an int for the account number. And then it'll take in a string for the name of the person, and it'll take in a string for the type. Okay, and then what we want to do is, now these are parameters to the constructor. So this argument gets put into that parameter. This argument goes into that parameter. I want to move that parameter into this field. I'm building an object and I want the object to hold the data. So that's where the this keyword is. I want this account number to be equal to the account number that's over here in the parameter. Okay, so there's the argument. It passed to this parameter, and I want that parameter to be copied into this field, this instance variable. If I create another bank account up here, I might create an account with ID number 456 for a user named Jane, and it's going to be a savings account. Okay, whoops. Now, see, that's a different argument to this same parameter. Then that argument will be copied to a different field because it's going to be in a different object. This creates one object, this creates another object. Whoops, bank account got an extra. Okay, this constructor is creating one instance holding these fields, and this constructor is creating a different instance holding these fields. So that argument will be copied into that parameter, then that parameter will be copied into this field of that object. Okay. All right, and then I keep doing this. This name equals name, and this type equals type. Okay, now I can watch myself build two bank accounts. If I typed everything right. Okay, so I'm going to, now notice constructors look a lot like method calls. So they're not methods, but they act a lot like them. You jump to the constructor, you pass parameters and arguments to the constructor, you do the data, you do the code in the constructor, then you go back up here. Okay, so constructors, they are not considered methods, but they act a lot like methods. Okay, so I'm going to jump down to the constructor. So from line 5, I'm building this object. So to build that, let's see, let me maximize this. See, I'm from line 5 in main, I'm doing the right-hand side of this line of code right now. I'm building the object. I jump down here to the constructor. The first thing the constructor does is build the empty object. Okay, notice it just built a very much an empty object. See, I haven't done my code here where I initialize these fields yet. Okay, so right now I've got an empty object that's now going to get initialized with my data. So now account number is going to be put into account number. So this argument, that parameter, well, see, the argument was this guy here. This argument got copied to this parameter. This argument got copied to this parameter. That's this. Now that parameter is going to be copied to this field. Oh, let's see. Yeah, this field. I'm sorry. Okay, so forward. There. See, the account number got copied to there. So this argument got copied into the object. Okay. Now, this arrow pointing at this person's name, that arrow is going to be copied into here so that that will also point to that same name, so that the object will share that name. Okay. So now this object has that string in the name, and then this object has that string as its type. Okay. Now we're done initializing the object. So now we can return to line 5. Okay, so now we're at the end of the constructor. We're going to return to line 5. Now we've done this. Now here's where the Java Visualizer causes a little bit of a goof up. The object we just built is sitting here. The Java Visualizer just doesn't show it to you right now. The Java Visualizer has done the right-hand side and built the object. What it needs to do now is declare the variable on the left-hand side. So it's about to declare the variable, and then when it's declared the variable, it can put the arrow in it to that object. And it seems that the visualizer can't show objects unless there's arrows pointing at them. So see, there's the object reappears with the arrow. It's a goof up on their part. They should have been able to show this object without there being an arrow pointing at it, because the object was there. It's just that we hadn't done the left-hand side of this equal sign yet. So if you go back one step, you're now at the point where the right-hand side's been done. The left-hand side's about to be done. So you click forward one more time, and the left-hand side gets done. That creates the variable and points the variable at the object. Now there's that bank account. So the bank account object with a default amount of money in it, it's got an account number, an owner, and it's a checking account, but no money was put in it yet. Okay, and then we do this again for another account. See, now from line 6, we go down here to here's an empty object ready for us to fill it in. So we start before our code even executes, we get an empty object, and then our code fills it in. We say initializes the object. The right word is that this code initializes the object. Okay, so the object gets initialized. Okay, now we're done initializing the object, so it's constructed. So we go back up to line 6. The object's really sitting there. The visualizer just doesn't show it because the visualizer's still got to do the left-hand side. It needs to create the reference variable. As soon as it creates the reference variable, it's got a place to put the arrow, so it makes the object reappear. So there's 2 savings account objects. Okay. Now let's write another constructor. This constructor didn't let us put money in the account, but you could just as easily say, well, when you create an account, you should be able to create an account with money in it already. So let's create an account that also takes a amount. Notice that we have 2 constructors that have different numbers of arguments. One constructor builds a bank account with an account number, a name, and a string, and a default value for the amount in the bank account. This one's going to let us set the amount. So now we're going to say this amount equals amount. Okay. And up here we can create a third account. And now we can use the new constructor. We can use the other constructor if we want. There's an account number. There's a name. We'll make this one another savings account. And we can put $22 into it. Okay. So now we create an account with an initial deposit into it. Now we still don't. Now notice that we're not sure how to deposit money in these accounts yet. That's one of the things we're going to keep going on and start working on. We want to start talking about methods that manipulate the accounts. Okay. So now we can just see that now we have two constructors. One that lets you initialize, that makes an initial deposit, and one that just creates an account that's got zero amount money in it. Okay. All right. So oh, what did I do wrong here? What did I didn't read the error message. Oh, misspelled it there. That's a type the L's next to K on the keyboard. Okay, so I had misspelled that one there. Okay. Okay, and you can go through, build one kind of account using one constructor, build another account using that same constructor. Now we're going to use the second constructor. Now Java looks at the name of the constructor and also how many arguments there are to decide which constructor to use. This is called overloaded constructors. There's two constructors with the same name, but one has 3 arguments, the other has 4 arguments. So Java looks at how many arguments there are and calls the appropriate constructor. So it can't look at only the name, it also has to look at the number of arguments. Okay. And so in this case, it's going to go to this constructor. It constructs the same blank object. See, the object, notice that these objects have 4 fields in them, even though there's only 3 parameters to the constructor. Even though there's only 3 parameters of the constructor, the object has 4 fields, and just one of the fields just keeps its default value. So it's real important to realize that this has still got 4 fields. It's just that one of the fields is the default value. Now we're going to initialize all 4 fields. Okay, so then we initialize the 4 fields. Now this object has got all its fields initialized, and it's got an amount in it. Okay. And we can go forward and return, and now we got 3 and there's our 3 objects. Okay. Notice this funny arrow here pointing into here. Right now, the visualizer is showing strings the wrong way. See, it's showing strings as if they were primitives. I should go over here, back to edit code, go down. Oh, let's see, it is checked off. Let's go back and look. It says show strings as not as, it shows strings as arrows, not as primitives, but it's still, it's actually showing, I wasn't even doing that the other day. See, it's showing this string as if it sat in that variable, but that variable holds an arrow. So that's supposed to be pointing an arrow out over here. The string Bob should be over here, and the string checking should be over here. Same with the string Jane. Now here it shows an arrow back to this string. That's because the string, that word savings can be stored in memory one time, and both those could share it. So there should be the word savings out here, and there should be 2 arrows pointing at savings. And I'm not sure why the visualizer is all of a sudden drawing these in such a funny way. Here it's showing a string as if there was a primitive variable, which usually it does. If you go back here and you uncheck this box, it does that all the time. See here, now it doesn't show any arrows. See, savings is here and savings is here, even though there's really one savings with two arrows pointing to it. So here it's showing all the strings as if they were primitives when they're not. And it's supposed to do it the right way when I check this. This is the first time I've seen it do some strings right and some strings wrong. See, there's Bob and checking. See, there's Bob and checking the right way. But see where it goofs up. Okay, see how it's sharing arrows? Now it goofed up. That Bob should be out here, and there should be an arrow to Bob. And that checking should be out here, just like it was here. See, name holds an arrow to the string Bob, and type holds an arrow to the string checking. So the visualizer goofs up a little bit right there. I don't know if they've changed something recently. I don't remember it. Yeah, in my experience, my memory was that once you check that little box, it always did strings the right way. But now it's falling back into treating strings as like they were primitives. But then it gets goofed up when it gets here. It's really sharing that one string between two fields. So the word savings is out here one time, and there's two different arrows to it. I don't even know if I can get the visualizer to show it that way. Let me just check. Oh, let me just check all their boxes. I have no idea if, let's see. Let me just check all these boxes, see if one of them fixes it. Yep. One of those other boxes helped fix the problem. Notice the picture gets a little bit messy. That's their motivation for simplifying it, because the picture can get a little bit messy with all these arrows. Okay, so bank account name points to the string Bob. Bank account type points to the string checking. Okay, here bank account type points to the string savings. But this is also a savings account, so it also points at that same string savings. There's no need having two, you don't need two copies of that string. You can just have both fields, and that's the way Java does it. It has only one copy of that string and has two fields point to it. So that's their motivation for drawing strings the wrong ways, because the picture gets a little bit messy. But I wonder which checkbox I checked that made it fix it. One of these extra checkboxes helped fix the problem. Now it's back to being slightly wrong. Okay, all right, but that now I kind of dwelling on that because that's what you have to remember for the, that's part of what you have to remember in terms of reviewing for the final exam. You should be able to remember how these memory diagrams should look like. You need to remember that string are always arrows, okay? Strings are always arrows. Reference variables hold arrows. Primitive variables hold values. Reference variables hold arrows. So they'll always hold an arrow to something. Okay? Okay. Now let's go. There's two constructors. That's good enough. Let's think about methods. So for example, these two bank accounts didn't have any money in them. So we should be able to make a deposit. We should be able to have a deposit method, a method that'll take a double Oh, actually, I'm going to change something. Amount's a bad name for this should be balance. That's usually the word people use. That's the balance in the account. Okay, so I'm going to call this balance because I'm going to use the word amount for how much to add to the balance. So choosing names is kind of good. So I'm going to use the word amount for the amount to add to the balance, and the amount in the account will be called the balance of the account. Okay, so I'm going to deposit an amount into the account. Okay, and I want this method to be public. Anybody should be able to call it. And it doesn't return anything, because what it's going to do is it's going to mutate the balance. It's going to change this value. So this is going to be what we call a mutator method. And that was one of the reading assignments. There's this section on mutator methods. See, that's what this section is about. Methods that modify the data in an object. Okay? So this is going to be a mutator. Okay, and what it's going to do is, well, it's going to do this balance. I'm going to add to the balance. I'm going to update the balance with the amount. Okay. All right. Now, watch me do something here. I'm going to go to account 1, and I'm going to do something funny. And I'm going to go to account 2 and do something funny. Okay. Now, both of these shouldn't be right. I should not be able to deposit negative $10 into an account. And I shouldn't be able to just reach inside an account and say, oh, I'm putting more money in the account. Right now, these will both work. If I go here to last, I see that this account's got a lot of money in it, and this account's got negative money in it. Okay, but it doesn't make sense to deposit negative amounts of money into an account. You can overdraw an account, but that's different than depositing a negative amount into account. It shouldn't be possible to deposit a negative amount. And the same thing's true over here. I shouldn't be able to create an account with negative $22 in it. That shouldn't make sense either. So here's a new idea. These methods should be double checking the data that they're putting into the account. So here's what I can do. Down here, where this constructor takes in a balance, it should check if balance, that's the parameter. If the parameter is negative, there's a problem. So I want to do something if that's the problem. Else, there's no problem. And then I want to put the money into the account. Okay. So the question is, what if somebody passes me a balance that's an initial balance that's negative? Well, what I'm going to do is I'm going to throw, now this isn't in the book, but the idea here is that when a constructor or a method sees that a parameter value is wrong, there should be some way of reporting an error. We want to keep our objects consistent. If we're going to write code to create what we think of as a bank account, our code should have logic to make sure that these numbers make sense. Okay, so a balance shouldn't start out negative. Now, it may be okay to have a negative balance. You can overdraw an account, but it makes no sense to create an account with a negative balance. So what I'm going to do here is here's just a line of code. I'm going to throw new error and give an error message. Okay, so there's an error message. Okay, cannot create account with negative balance. Okay, now let's see what happens here. Oops. No, no.
You're missing the R in throw.
Oh, notice that it changed color. See, it became a keyword in Java. See, that's just a variable name. Then when I spell it right, throw, it changes color a little bit because that's a keyword in the Java language. Throw error. Now what's going to happen now is, let me get to the, okay, now we're to the part where we're going to try to create a account with a negative balance. So we get down here, we create the empty account, and we need to initialize it. So start initializing it, initialize the account number, initialize the name, initialize the type. Now we check the balance parameter. It shouldn't be negative. But we see that the balance is negative, so we throw this error, and what it does is it just halts our program. See, it halts the program with an error message. Later on, like in next semester, if you continue on with Java and learn more, you'll see how to deal with these kinds of errors. Like you can, notice the word throw is used because you can actually catch the error. One part of a program can throw an error, another part of a program can catch the error, and then the program doesn't crash. The part that catches the error can do something to fix the error, like just ask the person to like redo the creating the account. So the word throw is very specific because it's meant to be the idea that one part of a program throws an error, another part of the program can catch the error and fix it. From our point of view, it's what we want is we want to keep our objects sane. We want to keep our objects in a way that makes sense. Okay. Now, what about over here? If somebody deposits, we shouldn't be able to deposit. Well, we can deposit. No, it doesn't make sense to deposit a negative number. You can overdraw an account, but that's when you withdraw. You should only get a negative balance if you overdraw an account. Okay. So it doesn't make sense to deposit. So I'm going to do the same thing here. I'm going to say if amount is negative, I'm going to throw an error. So if you try to deposit a negative amount, I'm going to say throw new error. Then I can give an error message. Cannot deposit a negative amount. Okay. All right. And spell throw right. Okay. All right. Now, if that's okay, if I don't throw the error, I go ahead and add the amount to the count. Okay. So I have a mutator method, but the mutator method checks its argument. It doesn't make sense to allow somebody to deposit a negative amount. Okay. All right. Now, another mutator method would be withdrawal. So let's look at what withdrawal would be. So we would need a public void, because withdrawal won't return anything. It'll just do something. It will withdraw a amount. Okay. Now, if you think about it, you don't withdraw a negative number. Okay. So I still want to do this check here. I want to say if the amount is, you cannot withdraw a negative amount. The numbers are always positive numbers. You deposit a positive number and you withdraw a positive number. Okay. Now, if the amount is okay, then I'm going to say, okay, now the difference between a deposit and withdrawal is for a withdrawal, you subtract the amount. But this can make the balance go negative. So here's what I'm going to do. Now I'm going to do a test. Oops. If balance, I want to check if a balance goes negative, there's a problem. So now I'm just going to say error So now this would trigger, in a real application, this would trigger something that catches this account is overdrawn error and handles billing the user for extra money, or maybe giving them an emergency loan or something like that. So the logic would be, I want to deposit something. I have to check. It doesn't make sense to deposit a negative number. So I check that they're not depositing a negative number. I do the deposit. Deposit means you subtract that amount from the balance. Then I check if their balance has gone negative. If their balance has gone negative, I throw an error, the account is overdrawn, so that it's going to halt my program, but in a more sophisticated program, this would trigger some logic that would then deal with the case that an account is overdrawn. Okay, notice that we want to put logic. This is part of what object-oriented programming is all about. You don't just have data. You have data with logic that keeps track of the data, makes sure it's consistent, make sure things working right. So it isn't just that I want a mutator. So this is another mutator method. But it's more than a mutator. It mutates and does some checking and does some testing, or how you would, it doesn't just mutate the data, it mutates it and checks the data. Same with over here. This thing doesn't just mutate, it checks things. So that's one of the important parts of this. Now, none of that would make any sense. None of this would make any sense if somebody could just do this. Just reach into account and put anything they want. Now, if you notice, if I go and visualize this, oh, wait a minute. I want to get rid of the bad, so I want to get rid of this and get rid of that. Okay. I still have a problem in that I'm going to step through creating all these accounts. Oop. This line here just took took account 2. So there's account 2. It's got a 0 balance. And it just said, oh, make the balance 1 million. Okay. But notice that bypassed any checking. Like I could have put a negative number in there. Notice that this would completely bypass the idea that you can't create an account with a negative balance. So see, I put a negative amount in there. Okay. Now, how do we stop that? How do we prevent somebody from just reaching into an account and making arbitrary changes to it? The answer is to make these things private. That means that they can only be modified by code that's inside the class. So all of these are going to become private. And this is an important part of object-oriented programming. All the logic in the world in these constructors and mutators are pointless if somebody can just reach into an object and make arbitrary changes to it. See, if you can reach into an object and make arbitrary changes, all this logic is for nothing. The only way to enforce this logic is to say that the only way to update the data in the object is through our methods. You must go through our constructors and through our deposit and withdraw method to do any mutating, to do anything with the object. Okay, you can't just reach in there and poke into the object. So now this won't compile. Balance is private access and bank account. Balance has private access. I can't just change it. Okay, so this is a real important feature of object-oriented programming, making these fields private. Now, by default, they're public. Notice that when there was no word here, they were like, if I delete that word, now these are private and this one's public, and now this one will work again. See, this one, now I can compile that. And I can run it. And I've got this negative amount because I didn't make balance private. Okay, so balance is probably the most important one of them to make private. So I'll make balance private so no one can just reach in and manipulate the amount in the account. Okay, so every field can be either public or private. Public means that you can access it this way, just by reaching into the field and putting a value in it. Private means the only way you can change the field is with something in the class. Okay. Now, what I'm going to do is Now we have mutator methods for, see, balance is mutable. Account number, we're going to leave that immutable. What do I mean by that? Well, I'm going to leave it immutable.
It cannot be changed.
And what would be the rationale for that?
Because if I have an account in my name, it shouldn't be changed at all to any other number. Then we'd lose the data connecting it to my name.
And what if you wanted a new account? What if you wanted to change a checking account to a savings account? What do the banks usually make you do?
Get a new account number.
Yeah, they make you close the old account and open a new one because the account numbers are immutable. You can't change what the account number is associated with. Now, so we'll make the account number immutable. Once you create a bank account, that account number can't be changed. Now, the way we enforce that is make it private, and then there's going to be no mutator method. Okay, now we will put a method down here for public int get account, because we need to be able to ask an account, what's your account number? And since it's private, we can't read the account number, so we have to ask for it. Oh, that should be get account number. Read this dot account number. So return the account number. That way, somebody could ask an account, what's your account number? And the account number will fetch it for them, but nobody can go in and set the account number. You can't change the account number. So this is what we call an accessor method. But there's not going to be a mutator method for account numbers. We're going to leave account numbers immutable. Okay? But we can access them, but not mutate them. Now, what about name? Should it be mutable or immutable?
I kind of say mutable because, like, you can change your last name if you get married.
Sure. Yeah, you obviously have the legal right to change your name anytime you want, and the bank account shouldn't be stopping you from doing that. And it would be really kind of silly of them to make you close an account and open a new account just because you change your name. So this one's going to be mutable. Okay, all right. Now, we could just make it public. So that would make it mutable. But I don't really want to do it that way. I would rather make it private and make somebody call my method to make, because if I make it private and then I go down here and I create a method called public void change name to string new name, I can kind of control what's going on here. For example, I could write code that says check for you could write code that says, whoever's doing this needs to double check that the person has the authority, that they're really the person they claim to be. So I can put code in there that do a check before I do this dot name equals new name. So there's the mutating. But by making it a private method and forcing someone to call my change name method, I can control things. I can make sure that the name I can make sure the name is valid. I can make sure that the person has the authority to change the name. So I could, there could be code here that does something, all right? As opposed to just making it public. If I made it public, it's mutable, but that lets anybody put anything they want in there. For example, here's something that people could do really bad. Suppose I did this public. Account to dot name equal. That's valid now. See, that mutated the name. What's wrong with that? What's kind of bad about that?
It's empty.
It's an empty string, so there won't be a name really. Now down here, I could do something like the following. if new name dot equals the empty name, I'm going to throw an error. Oh, see, I can prevent somebody down here if somebody gives me a new name that's equal to the empty string. I'll go down here and say throw new error. The error message will be okay. So I can catch the error. Okay. And then if I pass the test that that's not an empty string, then I'll change the name. And I could have other changes. I could have all the tests I want here. I could check that nobody's going to slip an empty name into an empty string into the name. Okay. So now, if I leave it public, I can do that now. So watch, let's visualize this. Here's account 2. Here's its name. See, it's got an empty string in it. See, I let that slip through because I had the name as public. Okay. With the name being public, my test in the change name is pointless. This test doesn't do me any good if the name string is public, because somebody can just reach in and change the name. Okay. Oh, notice this picture is getting kind of confusing. So actually, at this point, maybe to make these a little bit easier to read, let's uncheck these boxes. It does give us a cleaner looking picture over here. Okay, notice it gives us a lot cleaner looking picture. You have to remember that these are arrows. Bob is over here and checking is over here. That empty string is over here. Savings is over here. That savings is really pointing at that savings. But see, there's the empty name. Bad. That because I have right now the name field is public. That means my logic down here is pointless because people can bypass my logic. So, but if I can force them to use my logic by making this private. Now this guy's going to fail. He won't even compile. See, name has private access and bank account. So they're blocked from doing that also. Okay. So the point of object-oriented programming is to design these classes with data, constructors, and methods, but then also to put logic in the methods that when they manipulate the data, they pay attention to the data and make sure things are making sense. Don't do things that would stop people from updating values in random ways. Make sure that numbers make sense, like deposits aren't negative and balances don't go negative. Okay, like what else could we do with the bank account? Okay, let's see. We've got balance is mutable because you could deposit and withdraw. Okay, those are the two methods that make it mutable. You can do a deposit and you can do a withdrawal. Okay. Account number is immutable. Once you create a bank account, you do not change its account number. The string is going to be mutable because we gave them a change name. Okay. What about the type? Should that be mutable or immutable? What do you think a bank would usually say about that?
What did you say?
Should the type of the account be a mutable or immutable field? See, type is savings or checking.
Normally they're immutable and you can link them.
Pardon me?
I feel like normally they're immutable, but you can link them
Yeah,
together.
now, that would be another thing. You know, linking accounts is something like here, we could have a field that said linked accounts that would have one account pointing to another account. That would be something else you could add. So, you know, what's interesting here is you could do the following: private, linked, private bank account. You could link two accounts together. You could have one bank account point to another bank account. See, that's how you would do this in the programming sense. You could have one bank account pointing at another bank account. So you could have a checking account pointing at a savings account. Okay, so that would be something interesting we could do. Right now, we'll make the type immutable, because we'll say that once you open an account, it's a savings account, it stays a savings account. If you want it to be a checking account, you close it and, you know, open another account. Okay, and we could, you know, and we could link accounts together. Now, here's one thing: if the type is private and immutable, you still need to be able to ask, is this a checking account or this a savings account? So we need an accessor method down here: public string get type return this dot type. So we need to be able to ask what the type of an account is. And we also need it for the name. We can change the name, but since it's private, we can't see the name unless we ask for it. So we need a accessor method. So this is an accessor method for type. We need one for name. Notice how I'm writing lots of little methods. This is really typical of this kind of style of programming. Lots of little 1 and 2 line, at most 3 or 4 line methods. So this is going to return this dot name. If I don't provide this accessor method, then nobody can see the name in the account. Because the name is private, and so, you know, somebody could deposit money in the account by calling the deposit, but they wouldn't be able to ask what's the name on the account. Since we don't want to make this public, and we won't want it to be mutable. We want it to be we want it to be mutable, but in a controlled way. Since it's private, we need to say get name. So that's how you would read the name on an account. Okay, and this is how you would read the type on the account. Okay, so we need these accessor methods. When a field is private, you almost always give it an accessor method so that you could see it, and then you have to decide whether to give it a mutator method, whether you can change it or not. So when a field is private, you decide whether it should be mutable or not. If it's mutable, you give it, oh, now these are mutator methods. We didn't give the balance an access method. We don't know how to read the balance of the account. So down here, after withdraw and deposit, we should have a public double get balance. Notice I have to write lots of little methods. Okay, so here are methods for mutating the balance. You could deposit, but it checks to make sure that you're not depositing something dumb like a negative amount. You can withdraw. It makes sure you don't withdraw a negative amount. Then it makes sure that your balance didn't go negative. If your balance went negative, it throws an error. But then we need to have a separate method that just lets somebody ask what is the balance. So this just gets the balance. Okay, account number is immutable, so we only give it an accessor method. Okay, so this is the accessor method for the balance. This is a mutator method and a mutator method. Okay, Then for name, we have a mutator method. Oop, what did I do wrong? Here we have a mutator for the name, and here we have an accessor for the name. And for the type, it'll be immutable, so there's not going to be any mutator method, but you can ask for it. Okay? All right. Now, what's another thing we would like to be able to do? It'd be nice to be able to do the following. Be nice just to print an account and see what it looks like. Okay? Be nice to be able to print an account. Now, I can obviously do the following. Instead, so right now I can't do, if I do that, watch what happens. It printed something kind of garbagey. I asked it to print an account, and I got kind of an ugly looking output. What this is this is the address of that object in memory. Every object has something called an address in memory. So this is just saying a bank account at address blah, blah, blah. Okay, that's account 2. So that would be this one here. So this thing's sitting at address blah, 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 but that's not what I want. I really want to see what's the data. Now I can do the following. I can do system.out.println account2.getName, and then I can go, I could print the name, I could print the type, I could print the balance, let's see, what else do we, oh, an account number. I could print the but notice that's not as anywhere near as nice as be able to just say this. I'd like to be able to just say print the account instead of saying print name, print type, print balance. Now this will work, should work. See, I got Jane savings, 0 balance, account number 456. Okay, but what I really want is to be able to just say print the. I want this to work. So that's not so great for me. I'm going to comment that out. That's not what I want. To make this work, you write what's called a Tostring method. So down here at the bottom, I'm going to write another method. It has to be spelled this way, Tostring, because when you write a Tostring method, Java calls it automatically when you print the object. Notice that essentially what it is the same thing as if I wrote Tostring here, but I don't have to write that. I don't have to call that method myself. See, this method is going to convert the object to a string. I don't have to call that method. Java calls it for me automatically when it sees that I'm printing the object. Okay, so I'm going to write this method. Now, what I'm going to do is I'm going to come up with a nice way to print out everything that's in the account. So here's how I'm going to do it. Now, notice that I don't actually print anything in here. I do not write system.out.println in here. That would be a mistake. This method does not do any printing. The printing is done by that. What this method does is it returns a string. So what it's going to do is it's going to build a, here's what I'm going to do. String result equals, and I'm going to build a string. And then at the end, I'm going to return result. What I'm going to do is I'm going to start out with an empty string, and then I'm going to add things to it. So I'm going to start with result as an empty string. Then I'm going to say result equals result. I'm going to add on to it the person's name. Okay, so, well, I'll start with account number. So now I'm going to do it this way. Okay. So account number is this. Okay. And then I'm going to add a little bit more to this string.
You forgot the plus sign.
Oh, yeah, where did that go? See, result plus account number is, then add on the account number. Notice this space here, so there's a little bit of space between the is and that number, okay? Then I'm going to say, I'm going to add some more onto the string. Result plus owner is okay. And then I'm going to add another word. See, result equals result plus. Notice this result is the empty string. This result is the empty string with that added on to it. Then this result is all of these added together. So I'm growing this string. You don't have to write it this way, but this is a kind of a common way to write it so that you kind of think in terms of, first I want this in it, then I want this in it. Okay, so I'm just kind of building it up little bit by little bit. Now I'm going to add, I got the account number is, the owner is, the balances, let's see, the type is this dot type. And the last one, the balance is okay. Okay. So now I write. This is a common way to write toString by saying I'm going to produce a result. And I'm going to start off with it being the empty string. Then I'm going to add on to it the parts that I want it to hold, and then I'll return the result. You don't have to write it this way, but it's kind of a nice organized way to write it. Now let's see what this ends up looking like. If I go to the end, now notice that, what can I do to make this better? There's a couple things there's a couple ways I could make this better. Notice that what's wrong with it is right now.
There aren't spaces between the different add-ons and result. So
Yeah,
you could
well,
add either a space or a new line.
right now, there's nothing between that thing and this thing. So one possibility is I could put like at the end of this line, or I could put at the end of this line a plus quote comma space, for example. Okay, so that puts a comma space at the end of that line. Okay, I could put that at the end of each one of these, comma space, comma space. Now this one, I'll end it with a, not a comma space, but a period. Okay, visualize this. Okay, notice it reads as one long line, but it makes sense. Account number is, owner is, type of savings is. What else could I do maybe to make this a little bit better? What might else make this a little bit easier to read?
Insert a new line.
Yeah, instead of it being all one long line, I could choose to do the following. I could put a /n there instead of the space, and put a /n there instead of the space, and /n there. So now this will be on one line. It'll end with a comma, but then you'll go to the next line and you'll see that thing, which will end with a comma. You'll go to the next. The commas will tell you that it's like continuing, and then it ends with a period. That should end up looking pretty good. There. Account number is 456. Owner is Jane. Type is savings. The balance is 0. Okay, so now you have it. So now you can just say print the account. You don't have to print out all the fields yourself. Okay, so this is another typical thing you do with object-oriented programming. You give all your classes a toString so that you can print them. Now we've run out of time. One last thing that's real important is it'd be nice to be able to ask if two accounts are equal or not. So we should, but we don't have time, but we should write one last method, public Boolean equals, ask if this account is equal to we want to be able to compare two accounts. So here's another account. We want something that would say this account is equal to this other account, something that compares the accounts. And it would just go in and check if they have the same balance, the same account number, same name, and same type. In fact, you might only need to check the account number. Yeah, if the account number is truly unique, like it should be, the only thing you would really need to do here is return, actually, you really should only have to return this dot account number equal account dot account number. If the account numbers really mean something, then you can tell if two bank accounts are equal by just checking if they have the same account number. Okay, so you wouldn't have to check if they're the same name, because if the account numbers do what they're supposed to do, if the two accounts have the same account number, they actually are the same bank account. Okay, let's see, did I do that right? Make sure that compiles. No, let's see, what did I type wrong? Did I misspell one of those?
I mean, your logic operator is different. It should be two equal signs.
Oh, yeah, exactly. Yeah, two equal signs. Yeah, one equal sign, you can't, it doesn't make sense. It didn't like the, one equal sign doesn't give you a value you can return. So Java made it so that one equal sign won't return a value so that this thing won't compile. So you need two equal signs to check if they're equal to each other. Now, can I use double equal here? Or should I use dot equals? Last question. Is it okay to do double equals here, or should I do dot equals? No, I'm writing dot equals. When do you use double equal sign, and when do you use dot equals?
Well, dot equals would be calling on this method, so it would be circular logic.
No, because that would be dot equals on account number. So I wouldn't be calling dot equals, I wouldn't be circular, because the question is, should I call dot equals on account number, or should I use equal equals on account number? So on account number, do I use equals equals or dot equals? What kind of thing is account number? What's its type?
A number.
Yeah. And that's a primitive variable. See, it's a primitive, and you use equal equals on primitives, and you use dot equals on reference variables. And since bank account is a reference, an object, bank account needs equals, but its field account number is used equal equals. Okay. For example, up here, when I wanted to compare strings, see, I had to use dot equals. If I want to compare new name to the empty string, I can't use equal equals. It would not make sense to write. That's wrong. That doesn't work. See, if I'm going to compare strings, I have to use dot equals because it's a reference variable, not a primitive variable. Okay, so we've gone over, so let me quit there. Okay, so we've practiced writing a class. Notice what we've done is used all these words. Yeah, we've been going through and using all these words as we described writing a class. And that's what I want you to start thinking, like thinking of how all these words are used when you describe writing a class. Okay, so On Thursday, if anybody's got questions about the review problems, we can start with those. So if you have time to look at the review problems, if you have questions, you can ask about those on Thursday. Otherwise, we'll keep talking about more of these ideas of designing classes. We'll keep looking at more examples of this. Okay, so we'll stop there. Thursday will be, remember, Thursday's our last day of meeting, and next week is final exam week. We don't meet during final exam week. None of your classes should be meeting during final exam week, and the final exam will be a week from Thursday. Okay, and if you have questions about the homework or about any of this example, I'll put this example up on the course website right after class. And if you have any questions, send me an email or come to office hours. Okay, so I'll stop sharing and we'll meet again on Thursday. So goodbye.